afternoon, everyone. I almost said good morning. Um, Thank you for being here. My name is Ray. I'm a developer advocate at Google, and I've been a Java developer for a very long time. And part of my job is to actually reach out to the Java community because that's where I came from, and show the folks some of the latest and greatest technology that we have, in particular like the open source tools that's being created. And today I'm going to talk a little bit about some of the best practices for developing and deploying applications to Kubernetes, but also some of the tools that's being created, that's being open sourced around these. Aside from my day job, I also contribute to some open source software like JHipster. Anyone here use or heard about JHipster? Anyone? Yeah? OK, some folks, yeah. So I wrote one of the first Kubernetes generator for it as well. And I'm also the author of JDFert. Anyways, if you have any questions about this session today, you can find me on Twitter. You can direct message me at Satanism. And you can also find more information on my site, which is satanism.me. Aside from technology and work, I love to travel. I love to take photographs. And many years ago, I took a break in between my job. I was a backpacker. I was traveling around Asia. I traveled for about 4 months in Asia. And this photo is special to me because I came across this one city in China where I couldn't find a cheap hotel to stay. Everything was really expensive. They didn't have any hostels. So I didn't know what to do. So I asked around, and this random stranger, I don't know this person. I still don't know this person's name. This random stranger told me that, hey, if you take a bus to a desert, and if you walk 4 hours in the desert in the southwest direction, you will find a real oasis, and you can stay there for free. And I heard the word free. I asked, which bus do I take? So I went there. So how many people here hike in the desert before? Anyone? There's usually a few. Yeah, a few. By yourself? That's what I thought. Yeah, right. That's pretty impressive. Now, all of you, though, have walked on the beach, though, right? You walk on the beach. Yeah? It's not the same, just saying. It's not the same thing as walking on the beach. When somebody tells you to walk in one direction in the desert for 4 hours, what that means is essentially that you don't want to go left and right and veer off, right? Maybe you just miss the desert by 30 degrees or something, then you're kind of wouldn't be here today. So what you do is you go across anything that comes in front of you, scorpions, dead cows, skeletons, whatever, and sand dunes. And you can see from here there are lots and lots of sand dunes. So I had to go up and down these sand dunes. And the desert is really soft, the sand is soft, so every step that you take, you sink a little bit, and then you have to pull yourself out. It was hot, I was thirsty, and I got this compass, and I was holding water, and I was just like, oh, what did life choices, right? And then I was like, oh man, this feels like writing a old J2EE application back in the days. And I thought I was on vacation. I stepped away from that, and now I'm here again. So anyways, I guess the point here is that with the desert, the oasis was really, really beautiful. I got there, which is nice. But things was not so easy, right? To get there, it's a lot of hard work. And regardless of the stack that we're using, we're always trying to get to that state where we deploy to production. And the road is never easy. It doesn't matter what technology you use. The thing is that things will start off easy, and then as we bring more and more production readiness to it, things get more and more complex, right? It doesn't really matter whether it's J2EE or even today with newer technology. My job is to hopefully show you some of the ways, maybe be the compass, but even better to be the helicopter pilot to airdrop you into that place, right? So hopefully today you'll get to see and learn some of the tools that might be helpful to you. How many people here are using Kubernetes already? Everyone? Wow, majority of the room. That's awesome. And right, so I think that a lot of people knows Kubernetes already, even if you're not using it. You probably know a little bit about it because it's been around for about 3-4 years now. I think I spoke first. I demoed this maybe 4 years ago. I was able to show a YAML that will then be able to deploy into your cluster. And every one of these things could be a pod, which is like an instance of your app. And then you can scale the number of these instances out really, really easily by using a deployment or a replica set. And then you can put a service or a load balancer in the front, right? And then, of course, magic happens. And after 10 seconds, you see everything up and running. And we go off to the next job. However, that was easy back then. It's still easy now. But I think as we going to production more and more, right? Actually using some of these things, and things are getting more complex, right? And this is the stuff I want to talk about today. So first, let's start off with your app. I think that one of the takeaway that I have from working with some of my customers and also internally at Google, working a team where I onboard some of the internal teams onto cloud and using Kubernetes. One of the things that I realized is that, well, this is great, but you shouldn't design your app completely around Kubernetes, right? A lot of times people ask me, how do you run an app for Kubernetes? How do you do that? And to be honest, what I say is, don't think about Kubernetes, right? If you're an application developer, you should be thinking about your app. What that means is that you should be designing your app to the best way it can operate, regardless of the environment it's running on, because you never know where the app might ultimately end up with. What that means is that you really need to respect a lot of the good practices, and contracts between the lifecycle of your app and being able to scale out and scale in. All of those things has nothing to do with Kubernetes. These are just good design, right? But today we're going to take a look at some special things and special hooks that will help you to do even better job. That being said, I think that one of the foundation of it is just to build a 12-factor app to start with, and then refactor from there. Now, how many people here heard about 12-factor apps? Yeah, okay. How many people here are implementing all 12 factors? Wow. 11? 5? Yeah, okay. 1. Everyone should have 1 because the first factor is checking your code, right? So everyone should have 1. All right, good. So that's where I'm going to start with, right? I'm not going to go into these in detail, but just remember, it doesn't really matter where you run your app. Your app has to, have good design. And then the other thing that I learned is that, testing microservices in a real environment is pretty hard. And I talked to many folks, especially those from the Java community, to learn about their practices. And there are always 2 camps. There's a camp that is happy with Kubernetes, and there's a camp who are not happy with Kubernetes. The camps that's really happy with Kubernetes say this to me. They always do tests locally. They test everything locally. They mock everything. So you don't depend on the real running services for everything. And so you do mocking. If you need to talk to a remote thing, that's mock. Then you do wire mock. If you're using Spring, you can do Spring Cloud Contract, right? There are a lot of tools that helps you to do tests locally. And I think this is so important because a lot of times I see people starting off with this application and try to go to Kubernetes directly, but forget some of the fundamentals, right? We really need to make sure that we test locally. If for any reasons you actually need to test with an external service that happens to be in a container, like a MySQL database, PostgreSQL database, or something, or maybe a real service somewhere else, then maybe you can use test containers. So what this does is to bring containers down, and you can just use this container, starting it directly from your unit testing. Okay. Again, I'm not going to go into some of these things in detail because I think this is fundamental. All right. So let's get that out of the way. Just make sure you're running your app the way that you're supposed to. Kubernetes doesn't solve your application problems. I guess that's what I'm trying to say. And then once you have the app, then we move into containers. And a lot of the Kubernetes constructs is based on containers, right? Your app is going to be packaged into containers and all that. And the thing about containers is that I remember the days where it takes like a whole year for somebody to provision the environments for me, right? And then a whole year, or maybe half a year, to figure out what additional components I can add into that environment in prod. What JVM version, what native libraries, and Tomcat server, whatever. Somebody else is responsible for that, and so you have to wait for it. Now with containers, it's getting really interesting, which means that to some extent, all of us are able to decide on what that runtime environment should be and can be. What that also means is that we all have a lot of responsibility now, and we need to work together with other teams to figure out what makes sense to have in the runtime. Imagine if you're in an organization more than 1,000 people, with 100 teams, and every team has their own container image, running their own OpenJDK versions from 10 different distributions. Like, that may be very difficult to maintain. So you gotta be responsible for these, and also you gotta be responsible for all of the potential vulnerabilities that's introduced into these containers. But let's say you have an application right now, which I do. It's not by any means 12-factor, but it's pretty close. It's just a Spring Boot app, of course. How many people here use Spring and Spring Boot? See a show of hands. Wow, everyone. Nice. OK, very cool. So without too much explanation, right? I have a controller here. I got an endpoint that says hello, blah, blah, blah. Here's the name that I can pass in. But I also want to show like a configuration that I pass in from some like properties or external environmental variable. And here's my default value, which is dev. OK? So how do I turn this into a runtime image? There's usually a whole like hour talk that I had in just teaching folks about how to make a proper Docker file with all of the best practices. And one of the first things that we need to do is, of course, choose the JDK. And there are so many JDKs to choose from now. Different vendors, different distributions, but you got to choose one. But here's the thing, just make sure you choose one that is container aware. I hope that everyone here, how many people here know what JDK version you're running in containers? OK, half of the room. So please understand the versions, because the version is really important. Some of the versions don't support container out of the box, whereas the newer versions do. I guess in general, you should just run the newest version. But in case you don't, make sure it's 192 or above. I just show you a little snippet of what that difference is. And I think you can find some of this information online. But I just want to show you the major difference here. Now, if you just run, here I'm going to do a Docker run, with the memory of 256 megabytes. So that means your container can only use 256 megabytes of RAM. I'm going to limit it to 4 CPUs. That means I'm going to throttle you at 4 CPUs. But if you go over 256 megabytes of RAM, I'm going to stop the container. And then I'm using this older version of the JDK. And I'm just going to go see the max heap, right? And what this will show you is that max heap here is actually pretty big, right? This is something that everyone needs to be aware. I cannot stress this enough. I talk to new customers coming to the containers, and everybody kind of forget this, which is that the number of the max heap here, if you don't specify anything, older version of the JDK is going to go to the host of the machine rather than your container limit, and it's going to show you this ridiculously large heap size. I don't know. I'm very bad with this. I'm going to use Google and say bytes in megabyte. And see, that is, OK, never mind. Let me do a bytes in gigabyte. That means my max heap is 27 gigabyte, right? And what that also means is that if my container has a limit of 256, in Java, the JDK, the JVM, is going to try to use as much heap as possible when they need it before they garbage collect, you're going to definitely run out of space, right? So if you're using a newer version of the JDK, of course, you're going to see a radically different setting here by default. So by default, this will be set to a much smaller size because the JVM is container aware. It understands that you have a total of 256 megabytes. Similarly, if you are running on the older version of the JDK, if you print out the thread, I'm going to say thread for the GC thread. If you're using parallel GC, this is going to see the number of CPUs on the host rather than the container. So even though I limited to 4 CPUs, here you can clearly see it's using 13 threads, which is many more. The reason for 13 is because my host has 16 CPUs, and it just decided to use 13. Now, if you're using a newer version of the JDK, it doesn't exactly have this issue. But however, it does have the issue that it doesn't actually show you what GC this is using because parallel GC thread analysis is 0. However, if you explicitly enable it, so I'm going to say XX plus, what is that? Use parallel GC. Is that the flag, I hope? And now we can see that this number of threads is actually set to 4, which is the one that I wanted from my container spec, right? So long story short, just make sure you understand what JDK version you're running. And many times, I cannot repeat this enough, in the past 3-4 years, people come to me asking about, my container is running for a few days or for an hour, and I got owned and killed by Docker. What happened? This is usually why. However, there's more to it, because your JVM has 2 different type of memory usages in general. There's the heap, and then there's the native memory usage. And the heap is really easy to understand. We can say that, well, the max heap is 256. However, if your container has a limit of 256 megabytes, What that means is everything that your app is using, right? So this includes the heap size and the native memory usage of the JVM. What are those things? There's a really, really good breakdown about this by Cloud Foundry's memory calculator. Let me just go there real quick. Memory calculator, which is right here. Whoa. Yeah, right here. So the memory calculator will tell you what actually is being used by, or it will kind of estimate how much memory is going to be used. If you go to this page, it will take you the breakdown. In general, it's something like this. You got the heap size. You also have your code, which has to live in a meta space that's in potentially native memory. And then you got the stacks for the thread. So depending on how many threads you have, say you're using Tomcat, you have a max thread of 200. So that's 200 threads. And then your thread stack could be 1 megabyte large by default. So right off the bat, you're going to be using 200 megabytes more in addition to the heap, right? So just be aware of what this is. Now, in the newer version of the JVM, there's a really nice diagnostic you can do. I think it's called native memory tracking. Yeah, that's what it is. So what you can do is you can enable diagnostic VM options, and then you turn on the native memory tracking. You have to turn this on, by the way, in the JVM arguments, not via the environmental variables. You actually have to do this in the arguments. That's what I found out the hard way. But you actually have to do that. And then in the end, you said print NMT statistics. If you run your application this way, when your application quits, you're going to be able to see the breakdown between the heap size usage and also the native memory usage. And this is pretty important. You can see how much thread you have, how many threads, and how much memory is being used for each. This is pretty important if you're actually getting OOM killed. If you set the heap size much lower than your containers restriction, but you just couldn't figure out why are you still getting OOM killed, then the thing that I usually do is to just expand the amount of memory I can actually use, run this thing, and truly understand what is being used. Or like from here, you see that you have like classes. I don't know, like how many classes you got and stuff like that. And you can use the calculator too. So let me see if I can find this Cloud Foundry. Where's the calculator? There we go. So you can give it like how many classes you got and how many threads you're expecting and the total memory you have for your, in your environment. And it's going to, kind of give you the optimizations of your startup command. So this is really, really useful. Red Hat also has a startup script that helps you to configure the amount of memory that you can actually use. But it's really a function between, how much code you're actually loading and also the number of threads that you have. Okay. Whew. So with all that being out of the way, we're just in step 1. And then you have to follow the best practices of your container Docker file and stuff. There's a lot of it. Don't run as root. Don't run as root. Know what you're running. And then you get into the optimizations of, well, how big is that container? And then optimization of, well, if my jar is 100 megabytes large, do I have to download 100 megabytes every single time? Now, in all seriousness, no. Like, I think that in a production environment, 100 megabytes is probably okay. But the bigger thing is during the iteration development, whenever you have to push 100 megabytes, it may take a little time. So then we have these optimizations about fine jar and thin jar and stuff like that. The list kind of goes on. I have a whole hour of talk just on that. But now what I say is to just jib it. Now, how many people here heard about jib? Jib, yeah, oh, well, very few. That's great. So jib is a plugin that was created by Google that you can add to your Maven or your Gradle file. And it's just a plugin where you can say, I don't want to deal with Docker file. In fact, I don't even have Docker installed. I just want to create a container. Go figure out how to do it. So in this application that I got here, I can just simply add a plugin here called jib. Okay, let me make sure you can see it. So rather than writing the Docker file and trying to figure out how to best optimize your container, this is pretty much all I need to do. I add the plugin and I say to image. Now, when jib builds this container, it builds in 2 ways. I can build and push directly to a remote registry, or I can build directly to Docker daemon. And the one I'm going to use is just to say Maven Docker, sorry, not Docker, jib build, something like that. and it's going to get the latest base image. It uses the default base image, which is called distro list, but you can configure it, and do all the layering for you, and it pushes the layer, and you're done. Now this container image has been built, it's pushed, it follows most of the best practices, and that's pretty much it. Of course, if you want to change the base layer out, you can do that too. So I'm going to say from image, and I think I'm going to use the OpenJDK AAA JRE Slim, and that's how I can change the base image, right? It's really, really easy to see rather than looking at the Docker file. The other thing, though, is that from the container perspective, maybe I want to add in some of the JVM flags that I just showed you. So I can do that thing here too. So here I just added in a bunch of JVM flags. I can do this directly from my plugin. And so I'm doing the same JVM flag here just so I can see how much memory is being used. More than that, which is like what user should I be running this as? So within the container thing here, I can say, well, I don't want to run as root by default. So it depends on the base container. So unfortunately, most of our OpenJDK containers runs everything by default as root. So you really want to restrict this. So you can say, I'm going to run as nobody and no group, something like that. It depends on what the container actually has in their thing. So let me just go ahead and build this again. As you can see, this build now is really, really fast. Mostly because, oh, what is this? What does that say? Because manifest is unknown. Oh, yes, of course. Thank you so much. Like 8U, there we go, 8U222. Thank you so much. And let's see if that helps. Whew. So now we're just building the application, building the container. And as you can see, because my base image is already on Docker, in my registry, what Jeep does is really just pushing the differences in the different layers. And if you just change your app usually is like 100K or something less. You'll only push that much data across the wire, and that's it. Okay? Now, how many people think this image actually works? Wow, nobody. Neither do I. So let me go ahead and try this. So I'm going to say it's a little bigger TI, RM, that. Right? So hopefully this will start my application with the flags and running as non-root. And yeah, and you can see the number of processors and everything else. And it starts well, right? So that's how we can get a container up there in the first place. All right. Long story short, if you're new to the container stuff, if you try to write your own Docker file, just make sure you have it reviewed before it goes into production. Otherwise, just use Jib. It's much, much easier. Okay. Another thing, though, is that one of my pet peeves is that some of the application servers, especially like Tomcat or any other application server you may use traditionally, if you package that into container, you're going to run into some issue maybe after a few days. Basically, you're going to run out of space. What happens is that some of these applications, the more traditional servers, what they're going to do is to write the logs into a log file. And it's going to do this until you run out of space. Or in the traditional server architecture, you run this in the server, and there's a log rotator. The log rotator will figure out where your logs are, and it's going to rotate it out and just delete the old logs and or zip it and stuff like that, and get rid of the older logs that's older than a month or whatever. In containers, there's no log rotator, so whatever you write in that container file system, you'll be there until you delete that container. And if your application doesn't really go away, you're going to keep on writing your logs into that container file system on and on and on until you run out of space. This can actually happen. So if you're not using Spring Boot, because Spring Boot has this disabled by default, but if you're not using Spring Boot, just make sure your application does not write anything to the file system. What you should be doing is to print the log to stdout or use an API to store the logs. Okay? stdout is important because that's the contract in Kubernetes as well. Okay, so you have the container now. Let's deploy, and let's see what type of process we can actually go through. If you like to try everything locally, you can run Kubernetes locally. And there are things that you can use, like Minikube, or there are other things you can use to like K3s, K3d, and kind. I'm not going to go into this in detail, but just show of a hand. How many people here use Windows for your development? Okay. So for all of you, you might be stuck with Minikube. How many people here are using Linux for your development? Wow. Oh, that's very cool. So if you're using Linux, if you want to bring up a local Kubernetes environment, rather than running a VM that's also Linux, try this one thing. Try K3s. It's really, really easy to use. Basically, I'm going to go find a Linux environment here, right here. If I want to install K3s, I think this is what I do. I do curl. It's just really nice way to do it. You curl, and of course, you do this in production. No. Know what you're getting into, but you run curl, you install K3s. It's pretty smart. The script is really nice. It just downloads all the things you need for Kubernetes. It downloads the command line. It configures systemd for you, and out comes the Kubernetes node that you can use. And now you can do sudo kubectl get pods, and you have Kubernetes locally now. This is super, super useful. I really love this particular way of running Kubernetes locally. However, sometimes it's just too much for us to do this. Maybe if you're lucky, your company will have a completely remote cluster that you're able to use, in which case, just use that as well. But this is super nice if you want to debug and troubleshoot stuff locally. Okay? Cool. Now, the other thing about this is that K3s is capable of running containers that's built directly from into Docker. So a lot of these other tools, you have to use a remote registry. For this one, you can build your container using Jib. Just build it directly to your Docker daemon, and then you run K3s on the same Docker daemon. Then you're able to use the same Docker image without having to push and pull, which takes a long round trip. Okay. However, if you have a remote, then you have to deal with registry. Now, unfortunately, one of the things that I haven't seen so far is a really, really easy way to kind of generate this, the YAML files for you, right? So you wrote your application all without Kubernetes. You did everything, well designed and all that. Now you have to deploy it to test things out, maybe. So here's the hardest part, which is to write that YAML file. So the little trick I do is just to use the kubectl command line here. So I can go ahead and create a new directory called KAS. And what I'm going to do is to do this thing called kubectl create deployment. I can give it the name of the application and the name of the image I want to deploy. And the important thing here is to do the dry run and output the YAML file, and you output the file out. So what this will do is to basically, whatever it's going to generate and run in Kubernetes, it will just generate the file for you. Now, very, very important, dry run. Yeah. If you forgot about this, then it's going to actually deploy things into the cluster. Okay, so I'm going to do that really quick. And similarly, I can create a service as well. So I can kubectl create a service. That's a local load balancer. I got my port here. Oh, the port is wrong. So 8080 to 8080, right? And generate that file right there. Now, the key here is that you want to keep this base deployment as simple as possible. You don't want so much things in here. I think that it should just work when you deploy these two things. So here's the deployment. I'm going to zoom in here a little bit. I'm going to delete that. You do have to do some cleanup here, right? So as you can see, everything is pre-made for you, which is kind of nice. Similarly, for the service, just get rid of the things you don't need. Now, a couple of things that's pretty important here. While you keep it simple, you do need to configure a few very important things in Kubernetes. One more relevant in production is resources. This is how much resource your application is expected to use. And we have two things here. We have the request, which is the minimum of what I actually need. So for example, if I'm OK with, to start off with 256 megabytes of memory and 2 CPUs, the M means milli, so 2,000 divided 1,000 means 2, so 2,000 millis means 2 CPUs. That's how much I need at the minimum. And then we have something called the limit in Kubernetes, which you should also set. And this is the maximum. This is where I'm actually going to kill the container, right? So for example, if I, based on that calculator, on understanding how much memory I can really, really use, I'm going to set it here. That's the limit of how much that's the top limit before I get actually killed. And then the CPU, maybe 4,000 for CPUs, right? So we can set that. That's pretty easy. The next thing that you really have to consider is the health checks. Now, in Kubernetes, we have two different health checks that you really want to set. To be honest, if you don't have a choice, or if you're just want to get things started really, really quickly, the first one is readiness probe. This one I highly, highly recommend. You should always have this one. The reason why Kubernetes has two checks is because one of them is called the liveness probe. Okay. What that means is that this thing is going to run. If liveness probe fails, we're going to kill the container and restart it. So when you fail the liveness probe, you really want to make sure that you want to kill it, right? It's recoverable by just a restart. Readiness probe is really interesting. Readiness probe means when are you ready to accept traffic, okay? And a lot of times, it's really, really hard to decide, to be honest. You have to understand your application to figure out how to do this. Readiness probe depends on, are you ready to accept traffic? Now, in the most case, what you are ready on is when you know you can actually hit the application. So in that case, the path could be, in my case, I'm going to say name is equal to check, right? Or something more real that you know that your application is ready. That's one way to do it. Or if you have like an actuator or a health check that you know that when that health check is up and running and your application is ready to serve, then you can use that instead, okay? Now for the liveness probe, though, it's where you really want to just kill the app. So for example, in this case, for my application, I'm going to say, when I want to kill my app is if my actuator is unhealthy. What that may mean is that my database is not connecting, my thread pool has issues, or something else. My app is just like totally bad, and that's why I really want to just restart it and and see if it recovers. So you gotta be understanding really these two checks. Sometimes you might flip this around and say my readiness probe is the actuator, but a different endpoint because thinking about running update scenarios, what you also want to do is that when you are shutting down your application, you want to flip the readiness probe first to false so that Kubernetes will be able to not send traffic to you. And then you can wait for like 20 seconds or so and do a graceful shutdown, okay? And it's a more complicated strategy, but you just really have to figure out what's the best way for your application to become ready or not. However, there's one more thing that we can talk about, which is, well, by default, when Kubernetes is going to shut down your application, it's going to send you a signal. I think it's called sigterm. So it's going to send you a signal called sigterm. Your application supposedly should capture it. But a lot of the people don't. But you should capture it, and then you do your graceful shutdown. But because we know that a lot of people may not actually deal with this properly, so here's another thing you can do, which is to hook into the lifecycle. So in the lifecycle, we have something called pre-stop. What that means is that before I kill your container and before sigterm, I'm going to call you. I'm going to let you know first and tell you we're about to stop your container so you can gracefully shut down. And in here, we have different ways of triggering this. We have HTTP GET, exec, and TCP socket. So we can do the GET, and we can potentially do something like a path is to shut down. Now, if you're using Spring in Actuator, you have this one thing, which is the shutdown endpoint. So if I say shutdown endpoint enabled is true, then I can expose the shutdown endpoint that you can call. And similarly, we need to, let me zoom in here, the other way. You can also say you want to make sure that this endpoint is exposed, right? However, here's the kicker. The shutdown endpoint only accepts a post. What was that? I can't hear you. And here it's only a get, okay? So you gotta understand like what you're getting yourself into. So for example, if you do actuator shutdown, it's gonna do a get. All it's going to get back is sorry, I cannot respond to a get request. So you may have to do some hack around this to make sure you have a real shutdown hook. That being said, yeah, I found this out the hard way as well. That being said, also here we have the management endpoints exposing everything. Of course, you don't want to. So right, for example, if I run this thing right now, I'm going to be able to hit my website, but also being able to get to the actuator, which is bad. So what I typically do is to run this on a different port. So I put my management servers on a different port that's never exposed to the public internet. Okay, that's also pretty important. You need to know what you expose. And by doing this, you might be able to bypass some of the authentication if you are in a secure environment. And of course, what that means is I also need to change my health check here to 8081, right? So far, so good. We're just going through the motions of making some good decisions here, hopefully, for my app. However, when I really, really want to run this, here's the problem. To test it if I really want to do that, I'm going to say kubectl apply, kubectl apply f, and give it the directory, right? And I can deploy my app to do like a full test to figure out, like, did I get everything right? the issue with this, unfortunately, is that if you go change the code, now you got to do this cycle over and over again. If I change the code, I need to go do gib build again. I need to go and update, whatever, and I'm gonna do kubectl apply. And if I didn't change anything, if the YAML file didn't change, Kubernetes will say, well, you didn't change anything, and so it doesn't really actually restart any app, and so it doesn't actually take on the latest version of the app that you just push into the registry. And then what we do is we do kubectl delete everything, and we hope everything restart and reload and all of that, right? So what I want to show you is some other tools that we created. It's called Scaffold. And this is a tool that helps you with the iterative development cycle if you actually want to just try everything in the containers in Kubernetes along with the YAML files as well. So I'm going to go ahead and create a file here called scaffold.yaml, scaffold.yaml, and scaffold. OK. And here I can, it's almost like Docker Compose, except this is designed to run with Kubernetes. So basically, I say, well, what images do I have that I want to deploy? So for example, I want to say my Wise Coyote 827 Jeep demo. I think that's the name of my image. And then how is this thing going to be built? By default, it's going to look for the Docker file. So if you have Docker file that you carefully constructed, that's been reviewed, and is production ready, then you can use it. If you don't want to do that, then you can also use Jib. So all I need to do is to make sure that the builder that they use is Jib. And every time you run Scaffold in this iterative cycle, it's actually going to find your application and build the container with Jib. Okay? Now, of course, you can also give it more arguments here as well. So I'm going to say args. My favorite one is this one. Don't do this in production, but I'm going to say skip tests. Right? Just speed up a little bit more. And then I'm going to say deploy everything that's in star.yaml. Okay? Now, if you do it this way, you can run this from the command line. You can say scaffold dev. And this will start off this iterative development cycle. And there it is. So it's going to say, oh, let me compile your app. And then I'm going to create a container with Jib. And it's going to find those YAML files in KS directory. And then it will deploy everything for me. And that should do the trick, right? And whenever you change something in your file system that Jib is watching, it's going to go ahead and redeploy, recompile, redeploy everything for you. Okay. So for example, hopefully this works. If I come here and say hello 2, something like that. Save. Oh, not that one. Save. VI. Save. There we go. There we go. It detected the change. It's going to rebuild the app for me, and then it redeploys everything for me again. And this also happens for the YAML files too. So now, especially if you're changing YAML files a lot, this is a really, really easy way to just reapply. Whenever you change the YAML file, reapplies it for you. Super easy to use. Okay. Now, of course, I can also do this directly from the IDE. So for example, the open source tool that we built is called Cloud Code. And from there, we can go ahead and just run Scaffold directly from the IDE too. The only difference is that when it runs in IDE, it also sets up the pull forward for you. So if you are listening on port 8080 for your service, you'll automatically pull forward that to your local host as well. But one of my favorites is actually this one. If you run this in debug mode, what this will do is to go through Jib, go through Scaffold, sets up everything for you, compiles your code, and then creates the Jib container, and then also sets up the debugging ports for you, and then enable the debugger on your machine on this IDE. And now this app is running locally on my machine, but the debugger should be connected. And if that's the case, when it does connect, I should be able to debug my app. And if I go hit this endpoint now, I should be able to capture this breakpoint and debug. It's only for development purposes, of course, right? So that's pretty cool. Let me just stop this for now. I'm going to go back to the regular cycle and show you a few more things. The last thing I want to show you very quickly is we follow through some of the practices here. Now, the final piece to the puzzle is when you deploy into higher level environments, some of these configurations don't apply anymore, right? So for example, when you deploy to QA, you probably want to run more than one instance or test, right? Just to make sure everything still works in a clustered environment. When you go into production, many of these configuration might change, like the request and the limit. Like all of these things could change in different environments. Then what people do potentially is to create multiple directories, copy and paste all of these YAML files, multiple times, and every single time you change some of the parameters. If you're lucky, you use like a code generator or a templating tool to do it, or maybe you use something like Helm, which you make some of these values configurable. I want to show you something slightly different. Not many people know about this. The tool is actually called Customize. Okay, what that means is that I can do pretty much the same thing. So, for example, I'm going to just create a new directory here called directory called Customize, and I'm going to have my base application deploy. Remember, to keep it simple, I'm going to call it base. And I'm just going to copy these two things over. Eventually, I just have one, but for now, I'm just going to do the copy here. Okay, and then I'm going to create a file called customization, customization.yaml. Yeah, and then here I need to specify the API version. So there we go, customize, and the kind is customization. I don't know why I have to type this all the time, but all right. And then we can say resources, and what is in this customization context? I'm gonna customize the file called demo deployment.yaml, and another one is called demo service.yaml. Okay. And once I've done that, what I can do is, if I go back to this customized directory called base, I can do customize build. What this will do is to run through the customization.yaml, figure out what should be deployed based on the resources, and apply any type of transformation that we may add for different environments, and outcome the final YAML that we really, really want to deploy. And typically, people will check this in. So for example, if I am dealing with a QA environment, this is what I would do. I'll create a new directory here called QA. Okay, and then I will copy the customized file to QA. However, rather than repeating every single file that I know I want to deploy for my application, I can just refer the resources to ..base. Okay, and that will bring in everything that was in the base, which is my application deployment, which again, you gotta keep it simple. And the reason you can do that is because in Customize, you can then further change things. So for example, we can apply a patch. So here we can say like replicas patch, for example, .yaml, which I'm going to create. Well, what is this patch going to do? For example, I can create a new file called the replicas patch.yaml. And if the only thing I want to change is my deployment, and the only thing I want to change is the number of replicas, okay? So in this patch file, what I can do is to say, I need the coordinate, which is the API version, the kind, and the name. And then all I need to do is to change the replica to, say, 4. And if I go to the QA directory, do the customized build, what this will do is to grab everything from base, which I know runs with one instance, and then apply the patch. And then here we have replicas is equal to 4, right? And with this way, you can modify and update your environments very, very easily. And the beauty of this mechanism is that there's no variables. You're not really dealing with variables. You are dealing with the actual thing that you want to deploy, and they're just using the structure and merging everything in. Now, of course, you can do this with configurations too. So for example, if you ever need to have a configuration file, like my app config or app config, like something like that, you can also refer to the file, like application.properties. And this is very specific to the QA environment. So I'm going to create a new file here called application.properties. And within this file, I can do inf.name is equal to QA. And if I do customization again, if I do a build, it's going to run through everything under the transformations. And one of the things it's going to create is this config map, which is called app config. And notice it also added some name after it. That's because you don't really want to override your existing config. You actually, every time you roll out a new configuration, you should just update the version or the name of it. Okay? And then you can refer to this config file directly from your application. So for example, if I go back to the deployment here, if I really want to do this, right, I can do template, spec, container name is drip demo, and then I can say value mount, and I can say config. Let me zoom in here a little bit. I can say something like mount my config into config, and the name is config, right? And I can just do all of my configuration externally, okay? So for example, here I'm going to call this config, and it is a config map, and I'm going to refer to the name of app config that I just created. Now, again, if I rewrite this customized build, I'm going to see that now I have my config map that's mapped to the config that's being generated as well. So everything kind of ties up together. And you can replicate this for multiple different environments. Now, the last part of it is, of course, well, now you have 2 different YAML files, and now you got more YAML files. How do I run this and test this out in a single way within Scaffold? Right? So for example, another thing that you might do is that for the QA environment, you want to deploy into QA namespace. You just do namespace, and everything underneath this tree will have the namespace made for you as well. So how do I tie everything up together? Last bit of this is Scaffold. So rather than using kubectl, I'm going to get rid of all of these things. I'm going to say customize, and the path is customize base, for example, right? Because that's where the files are. And by doing this, I can stop my continuous loop. I can just rerun this whole thing again. Then now you're testing your YAML files, your customizations. You can even have different profiles. And you can even try to debug and troubleshoot. But as you're changing code, it becomes radically easier to do. Okay? So that's some of the tools I really want to show. Let me make sure we didn't miss anything. Okay. And with that time, thank you so much for being here. I really appreciate it. If you have questions, I'll be outside.